Okay, that's good.
Testa visst läge.
Ja, det har vi den. Great. Screen. Den okej.
Så syns väl du om du står här. Precis så syns du.
Ja, just det. Okay. Let's start this lecture. And let's see what happens using the live streaming facilities. Today we're going to discuss some more database design, and at the end I will once again walk you through that example that I had last lecture. We were talking about apartments and tenants and all those things that we tried to model. And for those of you that didn't attend the lecture physically, this is something new for you. And if you were here yesterday, this is a sort of a recap, a repetition. So let's go back to that picture once more. It tells you a bit about the life cycle of a database, and I've told you a few times now that if you look at it, you see that it starts with a sort of a requirements phase, which is really hard if you don't understand the problem, or if you have a customer that is not understanding the requirements himself or herself. And there's a lot of psychology involved in that phase. So if you have tried to determine your requirements, you will probably move over to the modeling phase, the logical design. And that logical design is sort of your way of emulating or simulating or trying to modeling the real world. So you are going to talk about entities and how they relate to each other. And when you're done with that, you're going to try to sort of transform your entities into tables, and those tables are to be implemented or created in a real database. But first, when you have sort of transformed your entities into those tables, you will also try to normalize things. And normalization is sometimes considered to be a bit difficult, but it's actually not if you are just using the first normalization forms. And we will use 3 or 4 of them. And what we will try to do is to try to remove redundancy and some relations between attributes that shouldn't be there. When you move over to the physical design and also the implementation in itself, you are also moving over your domain, your expert domain, and leave it over to an DBA admin, most likely. If you are to be employed by a smaller company, you are probably the database design expert as well as the DBA expert. So a DBA or database administrator is the person who sort of maintains the SQL server. And that person is probably and hopefully really good at optimizing the database you are creating for your needs. And these are the few elements that we have been talking about, and this is a recap as well. This is not the last time we will see and have a look at that picture. And if you have a look at it, you will see that there are 2 things here: the entity sets, or the entity, and the attributes. So for those of you who are Java programmers or C# programmers, the movie entity might, but shouldn't, be viewed as a class. and those attributes might be members or properties. But don't mix the entity with the class thing here. It's just there for if you're taking sort of a shortcut here, it might work, but in the end it won't. So those things you are looking at right now is entities, not classes. And the reason for me saying that is because I'm a UML guy myself. I'm an object-oriented person, so I sometimes change entities into classes and the other way around, and that usually ends up in a terrible mix. So if you have that movies entity set, you can instantiate or make instances of that movie entity, and what you have here is the name of the movie and the year it was produced, or at least released the first time. So you have the great movie Star Wars from 1977, and don't forget it, the 13th of December this year they will release the newest one. And then you have Mighty Ducks and also Wayne's World. So if you want to look at from an XML standpoint or NoSQL standpoint, you may have a look at the one to the right-hand side. So the graph version is to the left and the XML is to the right. And there you have a proper XML or HTML. I don't find that this is, let me put it that way, don't view it as entities of HTML or XML. Use those diagrams instead. And if you have entities, they also relate to each other in some certain point. And that is a relationship between two entities or three entities. That's a ternary relationship. That is a binary relationship. And the way you read it is that you start from one point, like a star stars in 0 or more movies, or a star stars in many movies, because the endpoint, the intersection between the line and the box, tells you the multiplicity of things. So if you read it the other way around, then a movie may contain many stars, and a star may also be part of many movies. Okay? So that thing over here is a multiplicity thing, and that goes for the other way, the other side as well. So that is your way of telling the world how these two entities relate to each other. Right? So if we would try to create some entities, some instances of it, then we could have a look at the Star Wars movie, and it has 2 stars, and that would be Carrie Fisher and Mark Hamill. Mighty Ducks doesn't have any stars, and Wayne's will have just 1, Mike Myers. So the thing you can have a look at here is that if you want to add another star to the Star Wars movie, then it's just a matter of making an association between the movie Star Wars and another star. And that is what that model tells you. So that's the model, and that's just a test view of your model. You can do that if you want to, that's fine by me. If you feel insecure about your model, just try to draw a few things here. draw a few instances of each entity and make a relationship between those. That's fine. And the matter of good design. It says here that it should be faithful to your model and to what you model, and that you should capture the real world. And the thing with that capture the real world is that sometimes you start to add entities that is not part of the real world. They are not part of your problem. And that goes with both the entities and the attributes. So in that sense, you should be a minimalist. Being a minimalist is good. And if someone tells you that that entity could be good to have in the future, then you shouldn't add it, because it is not a part of your problem. All right? And also that redundancy thing. Redundancy means that you are storing the same thing at several entities, several different entities, which means that sometimes you get a contradiction because you are storing a star named Carrie Fisher twice, and suddenly that Carrie Fisher changes her second name into some other name, and you sort of forget to change the first instance, and then you have a contradiction. Carrie has two second names, and which one is correct? But sometimes redundancy is really good, because you want to have it if you have a need for speed. A complex model might sometimes slow you down if you're asking it for some specific information. So you're storing information at several locations to speed things up. But that's a design decision. That's a design decision. It's not by mistake. So once again, if someone tells you that, okay, it could be good to have that value or that attribute stored on several locations or in several different entity sets, then you should stop it. Just stop it. And as it says here, simple is good, and that is like a mantra. Simple is good, but it's hard to get. Creating a complex system is very easy, but as soon as it gets complex, it is very hard to maintain. It is hard to add things. It's hard to change your model, because if you change it at one end, it will most likely affect some other end. And if you're affecting your model that way, you have to change your instantiated tables, the tables that you create when you create the database. And when you do that, you are affecting the programmers. The programmers are using your database and your tables. That might not be a problem when you are in the implementation phase, but as soon as that database has been released, it's live. It usually is a major trouble changing the behavior and the model of it. I'm trying to scare you a bit here. For a good reason, yeah. And also, that thing about using the right type of element, well, that means that sometimes you mix something that should be an entity for being an attribute, and the other way around. And then you also have that non-key thing, which we will be talking about later today. That's about referential integrity and identifying things uniquely. And that is also sometimes a real trouble. So that multiplicity. So if you have these three minor models, and if we start with the top one, well, how should we read that one? Well, if we start from the left and move over to the right, then we have that one instructor teaches at many courses, and one course may be taught by many instructors, which might be right or wrong, I don't know. If you take the middle model, we have one instructor might teach at one course, meaning really 0 or 1. And one course may be taught by one instructor, or a course might be taught by one instructor, which might mean 0 or 1. If we actually mean exactly 1, there's another symbol for that, and we'll get back to that later on. So the last one. One instructor might teach at many courses. One course might be taught by one instructor.
I have a question about the middle one.
Yeah.
So if one instructor is teaching one course, and the same course could then, going backwards, not have the same instructor, but that doesn't make any sense.
Exactly. So if a course would have had 2 instructors, then that course would have failed here. It would have been prohibited by the SQL server and your model. And that instructor might only be teaching at one course. So he cannot or she cannot be teaching at 2 courses.
Yeah, but it's 0 or 1.
Yeah, 0 or 1.
Yeah, so one teacher is teaching one course.
Yeah.
You have the same course. Could be 0 backwards.
Yeah.
But then
That makes no sense here. No.
Yeah.
Yeah. But that's what you're.
it's possible.
Yeah. According to the model, it's possible to have a course being taught by no instructor at all,
Yeah.
and maximum 1.
Yeah.
So, from that standpoint, your model is probably wrong.
Okay. But is there another sort of symbol that you use then that you have to have both true?
Yeah. Well, you can add a condition to it, just above it, and say put a. Let's see if I can change it over here. And I'm over here. Exactly 1.
But it doesn't have to be exactly 1. It
No.
has to be if the teacher is teaching one course, it has to be 1 backwards. It can't be 0 if he is.
Yeah. Well, I can model
I
it.
don't know if I'm just
No.
making any sense at all, but
And I think it's instructors. So an instructor teaches at exactly 1 course, and a course is being taught by exactly 1 instructor. But if that makes sense, that depends on what you are modeling. So this minimal model might be out of context here. Is that an answer to your question?
not really. It's hard to explain what I mean.
You can put some additional conditions here, so you can have it less or less than 4. But if you are having other conditions here that cannot be modeled using these types of symbols, then you have to add those constraints in the documentation. And that sometimes happens. So additional constraints goes into the documentation that you are creating. Such as if I am adding a name, what you cannot see here is the type of that name attribute. Is it it's probably a string. But that is something that goes into your documentation as well, unless you are using a tool like Enterprise Architect or something like that. And then you make that tool generate the documentation for you, if it's required. So sometimes the entity relationship model isn't enough for describing your view of the world, so you add that elsewhere.
Can you also force it like there shouldn't be any zero relation if integers be greater than 0?
Sorry?
Should it be greater than 0? Like at least there must be one instruction.
Yeah, sure. Sorry. And if you are really into it, you can add sometimes some additional constraints here as well, like you are supposed to have exactly either they should be more or equal to 7 or exactly 3, which might sound really strange here.
If we go back to what I meant, like if the first instructor is an instructor for the first course.
Yeah.
If you take the first course, it's possible that it doesn't have an instructor, but it has an instructor. Do you get what I mean?
Yeah. So if you try to put this into use, where should we put these instructors? Is it in the relationship? Teachers?
So they're not in the entity set.
Oh, sorry. The same instructor can be teaching at different courses, but there might not be the same course might not have more than one instructor. So the relationship is that the instructor is teaching a course.
0 or
Yeah.
0 or 1. I mean
0 or 1. And the other way around. So the same instructor cannot be teaching more than one. That's what you're.
No, I can ask you after class. It's weird. I feel like we can talk about this all day.
So that's just an instructor might teach at several courses. at many courses. But the same as a course might just have one associated instructor, or 1 or 0. Sometimes you just fall into traps here. But the way we are discussing things here is actually quite good, because if I was the creator of the system and you were the customer, we are actually having a good conversation here. We are not understanding each other. So I might not understand you and the other way around. I don't think that is bad.
No.
So we use the model for understanding the relationship between the producer and the customer of the system. And sometimes you use a UML model for that, and that's called a domain model, which is really good at that. It's a way of, it's more like you have a glossary of things, and you come to an understanding of how they relate to each other. So, redundancy. Okay, let's see here if we can switch over to the camera. And let's go for the next one. There you go. So redundancy. If you have a look at the left model, you can see that a movie is part of one studio, and that studio has the two attributes name and address. And that is fine, because if you change the address or the name of the studio, any movie that is associated with that studio also has the correct address to that studio. But if you move over to the right one, where you have just one entity called movies, and there you have studio name, and then you also have studio address. So for each new movie that you create, you are also adding the studio's name and address. Each time you create a new instance of that entity, you also added the studio name and the studio address. So if you change the studio name for one of those instances and forget to change it on the other ones, then you have that integrity problem. Which one of those studio names and addresses are correct? Can you see that? Yep. So the top one is the one that is more correct, and the lower one is the intermixed one, where you have the movies and the studio mixed. So that might not be a problem at this point, because you just have one instance of the Star Wars to the studio, and Mighty Ducks to the other studio, and Wayne's World to the Paramount studio. So if you are changing things here and creating a redundant entity, that is not a problem. But if you add another movie here that is also created by Fox, and can you see that on the top model things are fine here, because if I change the address from Hollywood to Stockholm, things are really fine for those two movies, A New Hope and The Empire Strikes Back. But if you move over to the lower one, which is the redundant one, and you have a look here, what happens if I change Star Wars that instance, I changed the address to Stockholm, but not the one that has the Empire Strikes Back. So the first one says Stockholm, and the second one says Hollywood. And that's where your problem starts. So if you are creating a redundant system by design, you really have to make sure that if you change it, your address from Hollywood to Stockholm for the Fox studios, you have to change them everywhere. And this is a very simple example. It's just one table here. But if you have 50 of those entities, there might be a problem. And sometimes when you have those one-to-one relationships, if you really have a look at it, you can sometimes just add them together and call them, let's say, just a movie, as they have here. But that is also by design. That is not something that you have made by mistake. And it might be hard to see it here, but as soon as you have a context to this, you have your problem statement given to you, you have been talking to your customer, you understand what you are supposed to do, then you might make the decision to add those movies and holdings entities together and call them just movies, because they are a one-to-one relation. And that is something that we have been talking about before, that redundancy is usually bad. And I did talk about this yesterday when we were talking about deducing things. That is something that you do when you are moving between your relationships to get your information. And we have also been talking about that database, that it may add too much space to it, so it cannot hold it. That's not true for most cases. Just go for it. Buy a bigger hard drive or use distributed databases. And the complexity is also something that we have been talking about. Reducing complexity is something that you will probably discuss a lot between your teammates or friends if you are going to create a project for something, because sometimes they look really good. For instance, the one to the right, where you have your movies, your stars, and your studios, and here we also see something that we haven't been talking about that much, and that is the attribute that is put on the relationship. So that means here that a specific combination of a movie and a star and a studio is pointing out a salary. So if we would put that salary attribute somewhere else, such as there at the studios, then it means that everyone attached to that studio is given the same salary. So putting it on the relationship seems to be a fine place to have it. And this is just a different way of viewing at things. I hope you remote students can see that. I have changed it from a fairly good one, which suits our needs here, but sometimes you don't need that thing. You just go for a simpler thing. saying that you have movies that have stars and the studios, and the relationship between the stars and the studios are works for instead. So this is why I've told you that explaining how these symbols work is fairly easy, but using them is sometimes quite hard. So depending on what you are trying to model, that one might work for you. It also depends on where you put your attributes. And this is something that I think that you will probably do at your first assignment, or at least the second one, and that is to get the attribute trace. You have just one entity and then you put all the attributes on it, because usually that is the easiest way to do things. If you take that entity and try to create a few instances of it, like the one I did show you earlier, where you have the Star Wars from 1977 related to a studio, and then you had the redundant table below it. If you take that massive entity that you have created with all those attributes and then you try to add value to it, just try to create a fake table, then you will probably see that, okay, this won't work. We have to redo things. And I think that that is something that you already do if you are attending Java classes or object-oriented classes. That is just analysis and design. So that is essentially the same thing. That's the attribute trace. You're starting to add everything into that movie entity instead of split it into movies and the studios entity. All right? I'm trying to nod here so you would do it as well. You're looking really sleepy here. Okay. Should we go for a 15-minute or a 10-minute break? 10 minutes or 15? 10. Okay, 10 minutes this is. Okay. Okay. Okay, let's see if we can start once again here. I think we're live. Hopefully. So, what would happen if we didn't care about that address of the studios? Could we sort of create just one entity of anyway? Well, yeah, possibly. It would be redundant, but it might be a bit better, and that might be something that we want by design. So, and that is our test view. We have populated our entities with the values here. So that is something that was what I was meaning when I told you can create a few test instances, create a few fake entities, instances, and tables. So this might be a bit better, but it's still redundant, but it might be there by design. So sometimes you can use a sort of a guideline. So if you have that entity set named E, so if those two conditions, 1 and 2, are true, then you can replace that E with one or more attributes. So if all the relationships in which E is involved, the one that is E is having the arrows into it. If that is true, then condition 1 is met. And the attribute of that entity E must collectively identify an identity. So that is something that we haven't been talking about, and that is the matter of uniqueness of an instance. I will get to that in a few moments. So if we try to apply those two rules or those two conditions to the model to the left, then we see that the arrow is pointing into studios. And we have that name and that attribute named address, so that won't work. So if we go to the right model, we have just that one attribute that is the key. Then it's just fine to incorporate that studio and make an attribute of it into movies, if that is what you want. So be careful when you are dealing with redundant information. So moving over to the concept of constraints, let's have a look at that model. If we try to find and look at each entity here, is there an attribute or a group of attributes that identifies an instance of that entity? Is it possible to find one for each of these three entities? Well, how do you identify a researcher? Given these 7 attributes of researcher, is there anything in there that uniquely identifies one researcher? Well, probably not. But if we have to select one or more, it would probably involve name. It's probably not going to be good enough in the end, but when we are talking about modeling that researcher entity, we're going to select the name as the attribute that uniquely identifies a researcher. And we might come to the conclusion that, okay, we have 2 researchers named Mark Hamill. They are working in different divisions, so okay, we come up with the idea that we are combining the name attribute and the division attribute. So suddenly we can separate these 2 marks. I mean, if I would uniquely identify one and each of you in here, I wouldn't go for the name. I would go for that identity that you are given by the Swedish authorities. That is something that uniquely identifies you. So that's what I'm meaning by that uniqueness. And the publication, well, the publication entity, the journal perhaps. Is there anything else we can use here? The ISSN number?
Yeah, the ISN, just for books or?
Yeah, I think so. Isn't that ISBN?
I think so.
Yeah. 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 So we might be selecting a combination of them or just one of them, depending on what we're trying to model here. The quality. Well, if we're going to uniquely identify an instance of that, if we're selecting the level alone, it will not be sufficient. So we're probably going for a combination of the level and the year. So suddenly we can have the level 1 and 2017 and level 1 and 2016, because the combinations of those 2 uniquely identifies an instance. So this tells you that every entity should have a key. Will that happen when you get into the real world? No. You will probably find a lot of solutions where you have entities where there are no keys at all, because they are created during great stress. Because when you are adding keys, you are also adding referential integrity. And that makes things a bit worse to model. But in the end, it is the only way to go here. So if someone is telling you that, okay, the system is down, you have exactly 5 minutes to fix that problem, then you don't start to talk about entity relationship models. You just fix it by adding a table containing a few columns or attributes, and then you go. So your system is using that table that is not following our recommendations or rules. It will work for, let's say, 2 years. Your system works for 2 years, and suddenly it stops. And that is because of your table containing no keys. So if you thought that you had troubles 2 years earlier with that 5 minutes, well, then you're in for a big surprise, because now you are in deep trouble. Okay. So that key might contain several attributes or combinations of them. So the instances of that key must be unique. It cannot be the same combination of values in it. If that will happen, your SQL server should stop you if you have implemented it correctly. And model-wise, you have to realize that really early. So, and there can also be many possible keys. We saw that in the previous diagram. We have a lot of combinations. We have a lot of design decisions to make. And sometimes it's not that easy to select the correct combinations of attributes being your key. And also when you have that is a hierarchy, all the attributes that you have down in the children will sort of pop up into the root. And what you do here is that every attribute that has an underline is part of the key. If you look at the movies entity, your key is a combination of the attributes title and year, meaning that you can have the same title twice as long as they are released in different years. So Mighty Ducks from 1997 might be released once again in 2007. Right? And that star entity, well, the name is probably not good enough, but that is what you have modeled here. That's the only thing you have. And also studios, which have the name attribute as its key. So how do you find those keys? Well, there is only one thing, that is you have to understand your problem and sort of have a look into the future. So you not only need to understand your data model, sometimes you also need to understand the functionality behind your system. What are you going to actually store here? How are you going to use it? So these discussions sometimes get really lengthy, and you will not be in agreement. There will be no consensus at all the first few days. But at the end, hopefully you will be. This is once again, this is a really good way of starting flame wars. I usually ask the customer or the product owner if you're using Scrum as your methodology or process. So there is actually no real good method for finding keys. You have to understand the problem and what you're supposed to do. But usually after a while you sort of realize that, okay, that's the key. And sometimes you add artificial attributes just to enforce that uniqueness. Some people do, using counters. Sometimes the only way to go. Sometimes it's just a bad design, bad behavior.
Why is it bad?
Because you will have that uniqueness by your counter, but you will have the same values there. and this is really a bad design. That's your personal ID. That uniquely identifies you as an entity. And somehow, suddenly you realize that, okay, I need actually to store my PID number twice. Your model doesn't behave the way you want, so you add a counter that enforces that uniqueness. That's an artificial one. It is added afterwards, just so you are getting around your bad design quickly. And sometimes that's the only way. Sometimes you're not even interested to have that uniqueness. If you are creating a search engine, a crawler, then probably you might be using artificial counters or artificial IDs.
There's not that many attributes that are unique. Just look at this one.
No.
Would you
There are not that many.
in that case?
So no, in that case, you have probably not read your requirements good enough, or your customer isn't understanding the problem. So you have to sort of, if you have a researcher, well, the employee number, tell them that you don't find anything that is uniquely identifying a researcher. I want an employee number in there. Then you have it. Okay. Yeah. I would really like to move over to the example that I had yesterday. Some of you did attend the lecture here physically. So in a few minutes I will stop this slideshow and move over to that example, and I will sort of explain the problem and try to create the model for you. There are a few flaws in it. Let's see if you can spot them. All right. So this is also one of those constraints, single value. And this is part of the discussion I have with you there. That single value constraint, you are supposed to have just 0 or 1 or just exactly 1. That's a constraint. And that constraint is created by those arrow symbols. There you go again. So that is actually a sort of a constraint. You're moving from many to 1. Many is not a constraint. So that referential integrity is also something that has to be enforced, and I'm going to see if I can show you an example of that using a fake table. So move over to that camera view again. So we have a relationship between a person and its car. And the reference here, we have, let's assume that we have, let's say we have me. From that standpoint, I am using owner ID to reference to the owner. I am referencing the owner using the owner ID, which on the car entity is just called owner ID, but as a person I have my PID. They are of the same type. If I add another one, that entity, the owner ID of 2, is referencing that one. If I would do this, I would actually remove that instance. That was me. Well, then that reference doesn't hold any longer. That owner ID is referencing something that doesn't exist. So we are not upholding the referential integrity here. That is sometimes things that happen when you're doing things quickly. They just go too fast, and this is something that you want your SQL server to enforce. You tell it that this is a referential integrity thing going on here. So if you try to remove that instance, your server will stop you. And that is also one of the ways to be collecting data from one entity over to another one. So suddenly we can ask questions. Who is the owner of the car having the register number ABC333? Because we have that referential integrity enforced here. If I would add myself back to it. And I could also ask, how many cars do Lars actually own? But that's not the referential integrity thing, but the other way around is. So, and that is what they mean by we sometimes want to assert exactly one. So. And the symbol is that half circle. Okay.
So this symbol, like, says that this is a constraint, that this one should match another movie, like one studio should match another movie.
Yeah, exactly. If you have a movie, then you also have a studio.
Mm-hmm.
Right. So, this is an interesting one. So what is the key for the contract entity? Yeah.
The combination of all three.
Yeah. So we need the identities from stars, studios, and movies, which should be the name of the star, the name of the studio, and the title and the year. Sorry, title and the year. All these four. Or do we actually need the year? Yes, we do, because we could have the same title. So we do need all four of those attributes as the key up here to identify a salary. But the names, you see, if you have a look at them, they are called name. So you have to separate the names when you pop them up there, and so you probably call them that the star's name, the studio's name, or something. Because if you have a look at what I wrote earlier on the whiteboard, the owner ID and the PID are actually meaning the same thing, but they are just having different names, and it's your referential integrity that enforces that, and that's your model. Let's jump weak entities for a while. (42). I don't think that if you are not into programming, that slide doesn't say that much actually. The only thing that is that class, the owns class, references the Star Wars entity and the Fox entity, and in this case it's the objects. So this would be one way of implementing it in a programming language, and it would be an I don't think it would be a very good database, but perhaps a simple one in a single chip and embedded system, perhaps. Let's skip that one. Yeah, okay. This is part of what we have been talking about, that redundancy, the deletion anomalies and the update anomalies. Let's go back to this thing again. This is a deletion anomaly when we are talking about referential integrity. When we're talking about redundancy is when you start to remove things that you shouldn't. So you're deleting an entity at a specific a specific instance at the specific entity, but you forget to remove it elsewhere. So you sort of have dangling instances here. You did forget to remove them all, which poses the question, did you forget to add them, or did you forget to delete them? And the update anomalies is what I was talking about earlier today when I changed, I think it was the Fox Studios from Hollywood to Stockholm. And suddenly we have Fox Studios in both Hollywood and Stockholm, but they actually do exist, it's just one place. So then you have a problem of deciding, is Stockholm correct or Hollywood? But once again, if you are doing redundancy by design, that is fine, because then you have it documented and you are most likely writing down why you want that redundancy. So if you can't explain it, don't do it. Okay. Let's see if we can do this example once more. So, yesterday we were talking about what if you were an owner of a building or a house, and in some of those buildings there were apartments, and you were actually renting some of them, and you find yourself in a situation where you have lost control. You don't know what you're doing. You are sending the wrong bill to the wrong person. So you come to the conclusion that, okay, I need to have a database here. So we need to model it first and make a model that is sound and it is actually doing what we wanted it to do. So yesterday I told you that let's have 10 minutes for you trying to create that model, but that won't happen today. So I will just sort of walk you through what we came to as a good conclusion. So it all started with the apartment, and I will try to make this visually as small as I possibly can, because the whiteboard is a lot smaller than yesterday, and the model got quite large at the end. So let's see if we can break it down. We had that apartment entity. That was something that we wanted to rent to people. And we used the word tenant. A tenant is someone who is wanting to rent an apartment. So a tenant might actually be renting several apartments. Right or wrong? I have no idea. We decided that, okay, a tenant might actually rent several apartments. So they have a contract. And an apartment can only be rented by one tenant, 0 or 1. And what we put as a relationship is the contract. The contract itself is the relationship between the apartment and the tenant. And then we started to add a name and that PID number as attributes to the tenant, and we also added an ID, an apartment ID as an attribute. And we also added a few more things like the number of rooms. And it probably will be a few more attributes to this. So once again, it's slightly out of context here. We also added a house or a building. Like that. So a house has many apartments, but an apartment can only be part of one house, and exactly one house. And once again, this might be a starting point for a good discussion, whether this should be house or building. Is that the same thing? And the other thing is the word tenant. I think that a tenant means that that is a person that actually has a contract or owns something, but our model says that a tenant might have many, which includes 0. So we might end up having a tenant owning nothing or renting nothing. So once again, a good starting point for a discussion whether that word tenant is good or not. And this might sound ridiculous. Why should we ever have this discussion? But when it comes to modeling, it is absolutely important that you have come to an agreement whether a word or an entity name is good or not for its purpose. So let's see. We also had this idea of what if all the apartments were rented, but you still had an interest in the one or two of the apartments in the house. Would that be possible to add that to the model? Well, we added person. This is where the model gets really ugly when your whiteboard is too small. So a person might be interested in many apartments, and an apartment might have many interested persons. And we added a phone number and a name as attributes. So if the owner of these buildings found out that there was a tenant leaving an apartment, he could probably call the first person in the list and tell him that, okay, we have one for renting now. Yeah, and also if something goes bad in your apartment and you need to call a service personnel, we added a service entity and specified needs. As its relationship or its association. So an apartment might be filing many service requests, but a service request or a need can only be associated with one apartment.
But it can't be 0.
Sorry?
It can't be 0.
It can be 0. Yeah, should we yeah.
Same thing for the person.
You want one here?
The other way. So the apartment. Let me see. No, the person exactly, but it deals with the person and the apartment. So there can't be a person without any interest, right?
Yeah, well,
there can be apartments that don't have any people that are interested in.
yeah.
Could be a 0 list.
If that's what we want to model. Once again, this might be a really good discussion whether it should be 1 or more or 0 or more. Once again, one of those flame wars starting here.
But it's more realistic to have 0 or more, because in the real world it can be the case.
Yeah, I'm just registering for waiting for something. Yeah. Yep.
Shouldn't the house also have service for the public?
Oh,
areas and stuff?
yeah. I don't exactly know what that should be here, or if it's is it a ternary thing here going on?
For the need, you
I don't know. But absolutely I agree. There should probably be a relationship between the service and the house somehow. But once again, this is something that you discuss with your customer, which in this case is myself. So that becomes me, myself, and I. And that usually ends up with a really, really good system. Yeah, let's see here. We also had that monthly payment. Yeah, we had, sorry, yeah, absolutely. So a contract may have many monthly payments that is due for a specific date, a due date. And we also had the fee, or how much the cost for it. And we also had a Boolean thing here called paid, so we know whether that monthly payment was paid or not. And we had a few entities on the contract relationship, the start and the end of it. I don't think that I can fit in more attributes here, but we had a few more in here, like account numbers and the standard fees and all that stuff. But using this model, you might start to create a system, or at least go into another iteration of it. So you get going. So there were a few questions whether that tenant thing here is okay or not, and a few other things. We couldn't really decide whether that relationship here, what's the name of it, and that might be a problem. Is that due to that we have an entity name that is wrong here? That's the wrong entity. So that was our discussion we had yesterday. So don't be afraid when you are doing these models. Don't be afraid of making mistakes, because this is a really good point in your development of your system, making bad decisions, because as long as you haven't implemented it and released it, you're sort of fine.
Maybe you can change the monthly payment to payment method, because maybe is the Willex payment or something, or just pay for
Payment?
yeah, just change it to the payment.
Yeah. Any other questions?
I think you can do something else that make the contract an entity and have the apartment have the relation to has, or have a contract like that, and then make the payment the relation between the contract and tenant.
Yeah. That would be an idea. Absolutely. I won't do it here. uh, and another thing is that if we were to find out some more of our requirements here, our model would probably change. Is that something that you can see in front of you here, that okay, this is the point where I want to make mistakes? And you are thinking really hard. I can see that on you. Yeah?
Yeah, because I'm stupid.
No? No, you're not. No, you're not. Absolutely not. You're deep into the troubles of modeling things. That's what you're doing right now. And what we might end up doing here actually is over-analyzing things. We are going to split those entities so badly that we have to actually add attributes to enforce the referential integrity and the uniqueness. That's probably something that you will see in your real-world experience out there in a few years, where you have tables containing one unique key and some strange column names. Just the key and the other column name, and then you have 10 of those tables, and you have no idea how they are related. That's the effect of over-analyzing things, which is the opposite of just making attributes of everything. Okay, that's it for today. See you on Monday.